Hey there, welcome back. Today we're going to talk about vector functions. So before we get to that, we want to remind ourselves what a function is. So the way I think about functions is I think about a function as a rule that applies to all elements of one set, and that's the domain of the function, to give an element of another set, and that's the codomain. All right, and why don't we call this first set x and the second set y? Then the range of a function f is the set of all little y in big Y that are hit by f. All right, so more technically, right, we say that is y is in the range of f if there exists, if there is an x, little x, in big X such that little y is equal to f of x. Right, and so what we're saying is we've got one set x, and for everything that's in x, we apply the function to it. It lands in y. Some of these points land on the same thing, but the important thing is that nothing in x has multiple places it goes. It has only one place where it goes. And we might be in the it might be the case that there are some elements in y that are not hit. This set of points that are hit, this is the range of f. All right, so that's the general idea about a function. And let's talk about where we've been up until this point. So as students of calculus, of single variable calculus, we've really been studying functions from R to R. So in calculus, up to this point, we have been studying functions of the form f going from R to R. All right, so when I write this, I'm being I'm being a little bit sloppy because what this means is that the domain of f, so this, which means the domain of f lies in R. It's a subset of R. And the range of f lies, not lines, lies in R. So this first part tells you where the domain lies. That doesn't mean that, let me actually, here's what I'm going to do. Let's use. So this R corresponds to this part, and this R corresponds to this part. So, for example, when we have the function y is equal to the square root of x, then the domain of this function, so think for a second, what's the domain of this function? Well, it's all the points that we can plug into the function, and you can only take the square root of a non-negative number. So the domain of this function is 0 to infinity, which is a subset of R. All right, and then the range, what numbers can possibly be the square root of another number? Well, if we take any number, any number that has been, for example, squared, so any positive number, if you take its square root, you can take the square root, you get the number back. So the range is, again, anything from 0 to infinity. And again, this is a subset of R. So what we can say is that even though we're writing here that it's a function from R to R, that doesn't mean that the domain is R, and it doesn't mean that the range is R. It's telling us what type of elements are put into the function and what type of elements come out of this function. All right, so that's talking about functions. Let's talk about the graph of a function, because when we get to vector functions, we're going to draw something, but it's not exactly the same thing as what we're used to when we're talking about the graph of a function. So the graph of a function y is equal to f of x. Right, so this is one of our standard functions, not when we think about a vector function. The graph of a function y equals f of x is the set of points that look like x comma f of x. So these are points in R2. They're points, they're coordinate points. They're the x comma y coordinates. And is often a line or curve or multiple curves. At least in many of the examples that we've seen, you normally draw a line, you draw a curve, or if it's a piecewise defined function, maybe it's a couple of different segments or some jumps. But in general, when we draw a graph, that's what it looks like. And so because f is a function, there is only one y value for every x value. Oops, haha, x value. So the graph of y equals f of x passes the so-called vertical line test. So if you draw the graph of a function, like y equals square root of x, then it passes the vertical line test. There's only one point on the graph on any vertical line that goes through. Okay, so that's a recap of functions, why don't I take a pause here because we're going to go and start talking about vector functions. See you shortly.